idea of solving a system of equations algebraically, and the first method that we're going to use is one that we call substitution. So think about the way we use the word substitution. If you're in a sporting event, if your coach substitutes someone for you, then you come out of the game and a replacement goes in, right? You're substituting. And so we're going to substitute one expression for a variable. Substitution method, it's a method of solving where a variable is isolated in one equation, then that expression is substituted into the other equation. Okay? So just like I've had substitute teachers, they replace me. All right? We're going to isolate a variable and then substitute that expression into another equation. So you remember how we reviewed how to isolate a variable? Well, this is when we're going to use that process. These are big picture ideas of how to do this. The first thing that you want to do is isolate a variable. It doesn't matter which one. Sometimes it's easier if you isolate a variable that has a coefficient of 1. All right, so in this example, 2x plus y equals 3. I'm going to isolate y because it has a coefficient of 1. Y equals 3 minus 2x. And I could also write it as negative 2x plus 3. That would be fine too. Once you have this isolated, then you're going to substitute the expression. The expression that I'm referring to is this part right here. We're going to substitute that expression into the other equation for the variable y. Okay? That's going to give us all one variable in that equation. And so then we're going to solve for that. We're going to solve for that variable. And then now we have a value for one of the letters. And now we're going to substitute again. We're going to go back into one of the original equations. And then we're going to check to see if that ordered pair really works. And then we're going to classify. So let's get underway here. Okay? Now sometimes they try and trick you and they tell you to isolate the variable and then they isolate it for you. And you're like, what? But that's okay. They've already isolated y for us here. This is done. So make a note here. Done. Don't have to do that. Now, this expression, negative 2x plus 7, I'm going to substitute into equation 1. Okay? So watch what I do. 5x, that's cool, minus 3y. But instead of writing y, I'm going to write negative 2x plus 7 and put parentheses around it. And then equals 23. See what we did? We substituted, we hit a y, and then we substituted negative 2x plus 7 in for it. Now I'm going to distribute. So I get 5x plus 6x minus 21 equals 23. I'm going to combine like things. 11x, 5x plus 6x means I have 11 of those x's. Minus 21 equals 23. Now I'm going to add 21 to both sides. And I get 11x is equal to 44. And I'm going to divide. X is equal to 4. So now I have a value for x. So now what I'm going to do is I'm going to substitute x equals 4 into, in this case, equation 2. So y is equal to negative 2 times 4 plus 7. And that's going to equal negative 1. So my ordered pair is 4, negative 1. And if I check it, I can just do quick mental math on this. 5 times 4 is 20. minus 3 times negative 1, so that goes plus 3. So 20 plus 3 is 23. Well, that works. And we know it works in the second one because that's what we use to solve it. So I have one solution. So when I classify, this is consistent, independent. Same thing. Same thing as when we graph it. Okay. Next equation, they didn't isolate for us, so now we have to. So I'm going to look at equation 1, and I notice that my x has a coefficient of 1, so I'm going to solve for x. I'm going to isolate x in equation 1. So I get x is equal to 2y plus 5. You could also write it as 5 plus 2y. Now I'm going to substitute 2y plus 5 into the other equation, equation 2. And when I do that, everywhere there's an x, I'm going to plug in 2y plus 5. So I have a 2 and I have an x. Oops, I'm not going to write x. I'm going to write 2y plus 5 minus 4y equals negative 4. I'm going to distribute. That gives me 4y plus 10 minus 4y is equal to negative 4. So when I do this, notice that my y's drop out, and I'm left with an equation that says 10 equals negative 4. Is that ever true? This is never true. That means these lines are parallel. And if they're parallel, I spelled that really bad. And if they're parallel, that means there's no solution. And if there's no solution, that means it is inconsistent. Right? Our next one. I'm going to isolate x again in this case. All right. So x equals 6y plus 5. Okay. Now I'm going to substitute 6y plus 5 into equation 2. Okay, wherever there's an x. So I have 2 times 6y plus 5 minus 12y equals 10. I'm going to distribute 12y plus 10 minus 12y is equal to 10. Here's another funny one. Notice how my y's drop out again. So that means I'm left with 10 equals 10. This is always true. So when it's always true, that means these two lines lie on top of each other. All the solutions to first equation are solutions to the second one. So there's an infinite number of solutions. And that means we are consistent because we have a solution. And then we are dependent. All right, here's our last one. Why don't you hit pause? Try this one on your own. Use the video question to answer it and see how you do. Okay, so none of my variables have a coefficient of 1, so I'm just going to pick equation 1 and I'm going to divide through by 2. I'm going to go negative 2x plus y is equal to 1. And now I'm going to solve for y. Y is equal to 2x plus 1. Now I'm going to substitute that in to equation 2. So now I have 4x minus 2 times 2x plus 1 is equal to negative 9. Now I'm going to distribute. 4x minus 4x minus 2 is equal to negative 9. These cancel, so I get negative 2 equals negative 9. That's never true. So there's no solution. So it's inconsistent. Right, here's the daily assignment, not the homework that we're going to use in class tomorrow. So oh, nope, I won't see you. Miss Notes will be there. All right, have a great day.